If you live in the Northeast, you've noticed this winter is different. The air feels sharper, the days seem shorter, and every morning brings a new layer of white blanketing the world outside your window. It's not just your imagination, this season has truly been extraordinary. The snow keeps piling up, and the cold is relentless. Streets that were once bustling are now muffled by thick snow, and the sound of shovels scraping the sidewalk has become a daily soundtrack. For many, it's a test of endurance and patience. After years of mild winters, this one came roaring back, breaking records for cold and snow. Local news stations are filled with stories of historic lows and snowfall totals not seen in decades. It's a winter that's rewriting the record books. Cities that barely saw snow recently are now buried. Neighborhoods are transformed into frozen landscapes, with snowdrifts reaching up to doorways and cars disappearing beneath the powder. The familiar has become almost unrecognizable. For some along the East Coast, this is tracking as one of the 5 coldest winters ever. People are bundling up in layers, bracing against biting winds, and sharing stories of past storms to make sense of what they're experiencing now. It's a reminder that even as the planet warms, nature can still deliver epic winter weather. The power of the atmosphere is on full display, showing us that extremes can still surprise us, no matter what the long-term trends suggest. So, what's behind this dramatic season? Why did the weather take such a sharp turn, and what made this winter so intense compared to recent years? It's a perfect recipe. Frigid Arctic air, abundant moisture, and storm systems all lining up. When these elements come together, the result is a winter that feels almost legendary. This year, all those ingredients were present in abundance. Each storm seemed to build on the last, with barely enough time to dig out before the next wave arrived. The relentless pace left little room for a thaw. We had frigid air plunging down from the Arctic, bringing temperatures that made even the hardiest Northeasterners shiver. The cold was so intense, it felt as if winter itself had tightened its grip on the region. The Atlantic Ocean played a unique role. Warmer than usual waters added extra moisture to the air, fueling storms and making each snowfall heavier and wetter than usual. The ocean's influence was felt far inland. Storm tracks were perfectly positioned to turn all that potential into piles of snow. Systems moved up the coast, drawing in cold air and moisture and unleashing blizzards that seemed to target the Northeast again and again. We'll dig into the science behind this snowy showdown, why February is so snowy, the role of ocean temperatures, and how this winter compares to recent trends. Meteorologists and climate scientists are working overtime to understand what made this season so exceptional. Understanding this winter helps us understand our climate better. Each storm, each cold snap, is a clue in the larger puzzle of how our world is changing and what we might expect in the years ahead. It shows us the powerful forces at play and gives us clues about what future winters might look like. Will this be a rare event or a sign of winters to come? Only time and science will tell. So grab a cup of hot cocoa and let's explore the epic winter of 2025 to 2026. Settle in, stay warm, and get ready to discover the stories, the science, and the surprises behind this unforgettable season. This is a season that will be talked about for years to come. Let's find out why, and what it means for the future of winters in the Northeast and beyond. February is the snowiest month for much of the Northeast. It's the time of year when winter truly flexes its muscles, blanketing cities and countryside alike in deep, powdery snow. For many, it's the month that defines what winter feels like: icy winds, frosted windows, and the world transformed into a silent, white wonderland. By now, the atmosphere is at its coldest, and the ground is frozen solid. The earth itself seems to lock in the chill, making it harder for any warmth to return. This deep freeze sets the stage for the most intense winter weather as the cold air lingers and builds. The jet stream dips far to the south, acting like a conveyor belt that guides frigid Arctic air into the region. This powerful river of air high above us not only brings the cold, but also helps spawn powerful nor'easters, those infamous winter storms that can paralyze entire cities. These storms tap into Atlantic moisture and combine it with a deep cold, producing the biggest snowfalls. When the cold air meets the moist air from the ocean, it's a recipe for blizzards that can dump feet of snow in just a day or two. The Atlantic is at its coldest, but still warmer than the air above it, creating instability that fuels storms. This temperature difference is crucial, as it helps storms grow stronger and more intense as they move up the coast. A storm moving over the relatively warm ocean can rapidly intensify, picking up enormous moisture. The ocean acts almost like a giant engine, feeding energy and water vapor into the atmosphere. This moisture falls as heavy snow when it meets the freezing air inland. The result? Thick blankets of snow that cover everything, from city streets to remote forests, creating scenes straight out of a postcard. This year, the classic February patterns have been supercharged: colder air, more frequent storms, and a particularly interesting role for the ocean. Meteorologists have noted that the storms are arriving in rapid succession, each one building on the last. All these factors created the snowy showdown we're experiencing. Neighborhoods are buried, roads are transformed into icy corridors, and communities come together to dig out and carry on. February is the king of winter months in the Northeast, delivering the kind of weather that defines the season. It's a time for snow days, sledding, and the unique beauty that only winter can bring. The ingredients have not just been present, they've been amplified. Each storm seems to outdo the last, with stronger winds, heavier snow, and colder temperatures. This is why February storms are so memorable. They leave lasting impressions, stories told for years, photos that capture the drama, and memories of both challenge and wonder. The science behind it is a perfect storm of timing and conditions. It's a dance between the atmosphere, the ocean, and the land, all coming together at just the right moment. This year, everything lined up for a historic winter. The records being set are a testament to just how powerful these natural forces can be when they align. Let's see how the Atlantic Ocean made it even more extreme, and why this winter will be remembered for years to come. The Atlantic Ocean's temperature is a major player in this winter's story. Its influence stretches far beyond the shoreline, shaping the weather patterns that millions experience each day. When the Atlantic cools, it doesn't just affect the water itself, it changes the very air above it, setting the stage for dramatic shifts in the season. This year, the ocean cooled much faster than normal, thanks to repeated blasts of Arctic air. Each surge of frigid wind from the north stripped away warmth, leaving the surface waters colder and colder with every passing week. The process was relentless, and the effects were soon felt all along the coast. By February, sea surface temperatures were up to 15 degrees, below average, from New England to the Carolinas. These are not small changes. Such a dramatic drop is rare, and it signals just how unusual this winter has been. That's a massive difference, showing just how persistent the cold has been. The ocean, usually a moderating force, became a reservoir of cold, reinforcing the chill in the air and amplifying the wintry feel across the region. You might think a colder ocean means weaker storms, but the temperature difference between ocean and air still fueled storm development. In fact, the sharp contrast created a perfect setup for intense nor'easters, as cold air clashed with any pockets of warmth that tried to move in. The cold ocean also meant drier, fluffier snow, and less chance of rain mixing in, especially for coastal cities like Boston and New York. Residents saw more powdery snow than usual, making for beautiful scenes, but also challenging conditions for travel and cleanup. The cold water locked in the cold pattern, acting as a barrier against warmer marine air. This invisible wall kept the region in a deep freeze, preventing any significant thaw and prolonging the wintry weather. When storms formed, they delivered pure snow. The cold ocean ensured that precipitation stayed frozen, leading to frequent whiteouts and deep snowpacks that blanketed the landscape. This rapid cooling of the Atlantic was a key reason for the exceptional snow and cold this winter. It's a reminder of how closely our weather is tied to the ocean's moods, and how quickly things can change when the balance tips. The ocean set the stage for a truly memorable season, one that will be talked about for years to come, as both a challenge and a wonder of nature's power. Epic snowstorms need a collision of cold Arctic air and moist ocean air. This winter, the polar vortex weakened, sending lobes of bone-chilling air south. That air is dry, so it needs moisture from the Atlantic to create snow. Even with a colder ocean, there was plenty of moisture for storms to tap. The ideal storm track passes just south and east of the coast, pulling Arctic air from the north and moisture from the ocean. The storm acts as a giant mixing bowl. Moist air rises over cold air, cools, and forms snowflakes. When this process covers a large area, you get a widespread heavy snowstorm. This winter's repeated storms, like the late January blizzard, were perfect examples of this collision. The result: historic snowfalls across the Northeast. It's the classic recipe for a legendary winter, and this year, it happened again and again. The impact of this winter has been felt from DC to Boston. New York City saw a dramatic turnaround, over 21 inches of snow by January's end, far above average. Philadelphia received nearly 16 inches, also well above normal, thanks to a major late January storm. Boston's persistent cold meant snow stuck around, creating towering snowbanks and classic winter scenes. Even Washington, D.C., saw higher than average snow, as cold air pushed the rain-snow line further south. This winter's storms were broad and impactful, not just hitting one city, but the entire corridor. The late January blizzard was a historic event, responsible for much of the season's totals. It was a shared experience of a truly memorable winter. Change is coming. Forecasts point to a significant warming trend for the Northeast as the jet stream shifts and milder air moves in. the back of winter's cold may be broken, at least for now. The Climate Prediction Center expects above normal temperatures for the rest of February. For those tired of shoveling, this is welcome news. Expect melting snow and hints of early spring. The season's biggest storms are likely behind us, but winter isn't over yet. Smaller storms or messy mixes are still possible, so keep your shovels handy. This rapid swing from record cold to warmth is classic weather whiplash, a pattern becoming more common in our changing climate. The coming thaw will be a relief, but the memory of this snowy showdown will last. Winter often has a few last surprises before spring arrives. How can we have a record cold winter in a warming world? The answer: weather is short-term, climate is long-term. This winter is a weather event, the planet's warming is a climate trend. The last 2 winters were the warmest on record, with little snow in major cities. This year's deep cold feels extreme because we'd grown used to mild winters. It's a return to the kind of winter that was common decades ago. Natural variability still plays a huge role. Sometimes, the right conditions override the warming trend. This season is an outlier, a dip in a graph that's trending upward. Long-term winters are getting warmer and shorter. One cold, snowy winter doesn't change that. It highlights the complexity of our climate system. Sometimes, the dance of patterns leads to a snowy showdown. The planet's warming, driven by fossil fuel pollution, is changing winter. Winter is the fastest warming season for most of the US, leading to less snow and shorter seasons. This affects water supplies and winter recreation, but climate change can also fuel extreme snowstorms. A warmer atmosphere holds more moisture, so storms can drop heavier precipitation. If it's cold enough, that means more snow. The rapidly warming Arctic may disrupt the polar vortex, sending more cold south. So, paradoxically, a warming world can bring both milder winters and sudden, intense cold snaps. We're seeing more weather whiplash, long warm spells, then record-breaking snow. The winter of 2025-2026 fits this pattern perfectly. We're losing the steady cold and snow of the past. Instead, we get winters of extremes, either too warm and brown, or intensely cold and white. This is the new reality of winter in a changing climate. What can we learn from this epic winter? Even in a warming world, the right mix of Arctic air, storm tracks, and ocean temperatures can bring historic cold and snow. But one snowy winter doesn't disprove climate change, just as one mild winter doesn't mean snow is gone forever. This season highlights our vulnerability to extreme weather and the need for resilient infrastructure. As the climate changes, we'll see more weather whiplash, mild periods punctuated by sudden, intense storms. The long-term trend is for warmer, shorter winters with less reliable snow. This winter was the exception, not the new rule. For every snowy showdown, we'll likely see several mild, open winters. Addressing fossil fuel pollution is key to shaping future winters. As the snow melts, we'll remember this season as a powerful chapter in our changing climate story.